this will be equal to 60 divided by shift pi divided by. It's 33.953 minus 33.953 times 10 to the power 3 psi. Let me do it again. 60 power 3 divided by shift pi divided by 751. Yep, 33.953 times 10 power 3. Okay. So it's in compression. So from here, what we're trying to find at the end of the day is we want to find our what? Determine the magnitude of the torque. So the torque, the formula for the torque is shear xy is equal to shear yx is equal to T R over all T. The torque about the y-axis multiplied by R divided by J. Okay. So if we were to reflect onto, we have to apply what? We have to apply Vorontz's criteria. Okay. So we have to apply. I'm going to write on a new page. We have to apply Vorontz's criteria that states that stress A squared minus normal stress A, normal stress B plus by stress B squared has to be less than stress U squared. Okay, so we know our U. So from here, before we carry on any further, right, by going back to our element, right, we have to sketch out 3D Mohs circle. I know you know how it looks like, but I'm going to show you the entire procedure. Okay, so we have to look at our element. The next thing we do, we have to sketch 3D Mohs circle. Okay, just a sketch. Okay, so this sketch will, okay, how is this sketch going to help us? This sketch, okay, this sketch will assist in finding the formula for stress A and stress B, right? If we apply Vorontz's criteria, they need to find what is stress A and stress B, which is the principal stresses. Okay, so now we sketch. Okay, just a sketch. So again, I'm going to focus on the negative side now because everything is in compression. Right? So this is our normal stress, clockwise, anti-clockwise, and we know that this is our point Z. Point Z has zero stress. Then we know that we have a compression, normal stress, and this compression is our stress X, stress Y. And this is our stress X and our stress Z line. And then we have our, again, we have our shear. Again, this is just a sketch. Okay, so these are our shear. You realize that we apply a lot of 2D Mohs circle theory, then we go into 3D, so easy, right? So Y is doing a, so if I label them now here, this is our point X, point Y, point Z. So we know that over here, this is our point Y element rotate clockwise. Point X, point X got not zero normal stress, but it has a shearing stress. From here, we can sketch a line, right? And then our average stress line is over here. And then we can draw our first small circle. Okay, how come I'm off again? Ah, that's why. So this is for our XY plane. Then the next circle, right? This next circle is for our XZ plane. And now find a circle. This circle over here, this is for our YZ plane. So we know that over here, this is our stress A. And over here, this is our stress B. So now the next thing we have to find is to find stress A and stress B. So to make our life easy, right? I like easy. So we know that from here to here, right? This is our stress average line. And then from here to here, right, let me over here from here to here. This is our radius of the circle, right? So from here we can don't immediately like put in the formula and try to calculate, okay? See, you can put the formula in its simplest form first, okay? What do I mean by simplest form? If you look at what we have done earlier, right? Right, if we have done our, this is von Mises, right? We can determine what is our stress average and then radius of circle. And based on this condition, tau max is sigma or normal stress max minus normal stress mean divided by 2. And then we put into here, and then when we plug in what is stress max and stress mean, eventually we have tau max experiment equal to tau max due to analysis. So it's so much easy, okay, rather than putting the value in. So again, we are going to do the same, right? So what do I mean? We are going to do the same. So we know that based on von Mises criteria, we have to have this form stress A squared minus stress A stress B minus stress B. So we know that stress A and stress B. Let me change. We know that stress A and stress B is equal to stress average plus minus by tau max. Okay, we know that tau max, or I'm going to call it radius, R. Okay, where R correspond to the radius of the biggest radius, or tau max for 3D mole circle. Okay. So we know that we are going to be in the form So based on von Mises criteria, we have stress A squared minus stress A, stress B, plus by stress B squared. And this is equal to 0. So we are going to let stress A is equal to stress average plus R. And we're going to let stress B is equal to stress average minus R. Okay, so I'm going to flip the sides. Okay, so this is my stress B. And over here, this is my stress A. Okay. So from here, we're going to put everything in. Okay, so we're going to put stress average plus by R squared minus by stress average plus by R, stress average minus R, plus by stress average minus R, the whole thing squared, 0. Okay, so we expand the term. Plus by R squared. So minus by stress average squared minus stress average squared. This one times the minus and minus R squared. Right, then plus by stress average squared minus by 2 stress average R plus by R squared, the whole thing. Oh, it's not equal to 0, sorry. Has to be less. Sorry, this is not equal to 0. Okay, stress U. So when we expand the term, or what we can get rid, we can get rid of this, we can get rid of this, right? We can the stress average squared. Okay, so stress average squared, you can get rid of this, we can get rid of this, right? So in the end, we only left with stress average squared. R squared minus minus is plus. Okay, so plus 3R squared, right? And this has to be equal to stress U squared. Okay. So this, okay, is our equation number 2, right? So our objective from here, okay, objective from equation 2 is to what? Determine R value. Okay, because we know our stress here, we can compute our stress average, right? We can compute because the stress average is equal to what? Stress X plus by stress Y divided by 2. Okay, then we from here we can determine R, okay, which is our tau max. Okay, so what I propose now, we go for 5 minutes short break. We come back in 5 minutes time.